wish it would let me get on so that I could help.
I have to cut and paste and put them in.
Okay. I'm gonna grab my other computer to see if that one will load.
That would be a nice thing.
Yeah.
Actually, this is going to be a paired sample, wouldn't it not?
I have no idea. I'm not quite even sure what the question is.
I guess we'll have to pray over your computer then, Hannah, McKenna.
Yeah, it's an interesting thing. This one works.
Good.
It's at least letting me log in.
That's a good thing.
Yeah.
Because I have to see things to comprehend them most of the time.
Yeah, me too. I can't listen and understand. Oh, no, still not letting me do it. So, I wonder if I typed it in wrong. My work password and my school password are similar but different. So I type it in wrong a lot. No, it's not letting me even sign in now. No. Okay. I guess maybe you work tonight, right?
Yep. We'll do what we can do here.
Yeah. It's frustrating. It's not like it's the BYU page that's down because you've got it pulled up.
I pasted my one column and one line down, so I got to delete it and start over.
Okay. So is this, you're just entering it into that Excel spreadsheet?
Yeah, and the QIP.
Okay.
There we go.
Yeah, I still cannot get it. Oh, I wonder if my phone will let me do it. Let me try that.
Do you have web on your phone?
Yeah.
Well, you're trying all sources here.
Yeah. I had the video up at work on my break listening to it, but oh, hey, this one's working.
It says here on question the information for the next 6 questions. Use the data files in the dentist's office bills. This data represents a simple random sample of dental bills at a dentist's office in Idaho Falls and a dentist's office in Rexburg. Let mu1 be the mean bill at Idaho Falls office and let mu2 be a mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho office is less than the mean bill at the Rexburg office, which means we will have a null hypothesis equal the mu minus equals mu2. An alternative hypothesis will be mu1 is less than mu2. Use the level of significance 0, 1, 10.
Okay. Getting it open. Ah, it opened finally.
All
Okay.
right. Good.
We're on number 5, right? Okay.
Yep.
Oh, 6. Okay.
Question 6.
The next 6 questions are definitely. Okay.
Well, I'm thankful that something got opened.
Yeah, I know. Sorry, because this computer doesn't have like everything saved to it like my other ones do.
Wonder if it's your internet or what it is.
I don't know, because one computer's working, so. So now I need to go find the quantitative inference thing. Because I don't have it saved to this computer. Sorry.
Well, we have to change the type of test. It's going to be less than for our type of test in our Excel paired sample t-test, okay? When you get to that point, when you got your stuff pasted in. Is this your 3rd attempt on a different computer?
It's like my 5th attempt, but I did it on my phone and my like main computer, and those didn't work. And then I'm using my husband's computer, but I don't usually use it, so it doesn't have all of my like saved files on it.
Yeah. So you have to start from scratch.
Yeah.
At least you have a backup.
Yeah. Is it the quantitative? Oh, here it is. Inference procedures, right?
We're using the dentist for the first 6 questions. So we're on question number 6.
Okay.
It's asking what is the degrees of freedom. Use it, the level of significance equals 0.10. So we're going to have to open up our applet.
Okay. I'm just barely getting the data entered, and then I'll be useful. Okay.
Shoot, it kicked me out.
So our degrees of freedom would be 19, right?
No, it would not be.
Because isn't degree of freedom n minus 1?
On my other test, I got that wrong, just minusing the n. There's another way to do it. Degrees of difference is d minus n. Degrees of freedom, 19, it says. I'm putting that in, so it's going to be, if degrees of freedom, it says in the paired sample test is 19, it'd be minus 1, would it not?
Sorry, say that again.
Are you in your office, your summary statistics and stuff? It says in the paired sample t-test, degrees of difference is DF is 19 under the null hypothesis of, we have to change the hypothesis. The null hypothesis is going to be 10. Or is that
let me see. Wow, where did I go? No, the 0.10 is a level of significance. So that you only use that at the very end to determine if it's null or you can't reject it, or if you can or can't reject it. The null hypothesis is that the mean of both sample data are equal to each other. So that's kind of what they're guessing, and then the alternative hypothesis is that the mean of the first sample is less than the mean of the second sample.
Going up into our little thing, it says confidence level. Is our confidence level 0.95% on your screen?
It doesn't say. But
Under
that
this,
won't change our degrees of freedom. So that's okay. Are you doing it under the paired sample in,
yes,
shouldn't it be the 2-sample test?
I'm doing,
Because they're not paired.
maybe that's what I'm doing wrong then. That's why I'm getting wrong information. So let
'Cause
me
maybe,
do that.
I don't know. I don't know that that's true. I'm just, from what I kind of got out of it. So when you go to the bottom, you know that you can click 1-sample t-test, paired sample
Yeah.
t-test, 2-sample.
I think I got into the wrong one. So let me redo this.
Okay, I think that might help.
Thank you for pointing that out to me.
No problem.
Moving on here. Two-sample mean tests. The difference in this two-sample test, the DF is 37.996. Do you see that on your bottom two-sample test?
Yeah, I see it. That's what I got as well.
It's nice that I can get into the right test, right? Thank you for that pointer.
No problem.
Number 7. What is the sample deviation for Rexburg?
So that's the second one, right? Yeah. So that's variable 2. So I got 206.637.
206.637.
Yep, that's what I got.
It's nice to be able to do this and not do all the math with it.
Yeah, I know. I like this program.
But you got to get the right form and all that. What is this test statistic? That's a test is negative 0.434. Do you see that?
Uh-huh. Okay. What is the p-value?
Number 9, what is the p-value? That's 0.0333.
Out of curiosity, I'm just going to put it into the applet thing, see if I get the same thing. Just because I don't know if, like...
Trust it?
Yeah, make sure. 0. It is 0. Yep, that's what it gives you the same one.
Thank you for your thoroughness, McKenna.
I was curious if I did it that way during the test, if I'd get it wrong. Because I always want to do that. For some reason, my mind goes to that, so I want to make sure I don't.
Well, it says if you want to use the null, so. Or the applet. Question 10, what is the correct decision based on this evidence? Well, P is more than our null. So fail to reject the null hypothesis. What say ye?
Yeah. Fail to reject. Yeah. Oh, wait. Because our null hypothesis is that
It's 0.
Okay.
But let's go back up and look at the question.
No. Oh, wait. What the heck? Oh, okay, yeah. So we just failed to reject. No, we do reject it. Because it is greater. Oh, but it's not. Because the null hypothesis is saying that it's equal to, but it's not, so then we reject it, right? Or is that wrong?
Whoa. We can look it up.
Oh, so if the p-value is greater than the level of significance, we fail to reject the null hypothesis. So you're right, we fail to reject it. And that's in the textbook. In chapter 13.
Chapter 13. Because our level of significance is 0.05. Our P is 0.333. So it is greater. So P is greater than the level of significance, so we reject the null hypothesis.
Okay.
11. Suppose instead that you had used the alternative hypothesis, U1 not equal to U2. What is the correct decision based on this evidence? A is we have sufficient evidence that the mean decibels between the two cities are different.
So I think it would be that one, right?
We have insufficient evidence that the mean decibels between the two cities are different.
I would say we have sufficient evidence to say that they are different. The first one.
Got to look at the information here to see if what supports the theory. The other two are we have sufficient evidence that the mean decibels between the two cities are the same. Let's look at the means. The means are not different. They are different. We have insufficient evidence that the mean decibel between the two cities are the same. We have the two means here. It says here we have insufficient evidence that the mean decibels between the two cities are different.
So if we have the two means, then we have sufficient evidence, right? that they are different.
But are they that different?
Yes, because the level of significance is 0.10, and the mean for variable 1 is 260.059, and the mean for variable number 2 is 288. So it's 20 point so instead of 0.10.
And we have a sample size of 24. Is that a is that under a level of what is the sample size that they want? They want 30 or more. So I'm saying that it's insufficient because we don't have a adequate sample size.
Okay.
So we don't have enough evidence. Does that make sense?
Mm-hmm. That does make sense. Okay.
Now we open up another one.
Hey.
Hooray, huh?
Yeah.
Well, here we go again. Pasting and cutting.
By the end of this class, I'm going to be great at copying and pasting.
Yep. I got to cut and paste this up to my thing again. A real pioneer in this stuff. Whoops, I X'd out of things. Now I have to go find it again. I get too click happy. Here we go. We got our freshman dinner again here. Let's move this down and click it up into our Excel. Whew. You have to really be a pioneer to do this. Okay, now we need to find out which kind of chart we have to paste it in. For the next 6 questions, use the data file freshman dinner. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let the mu1 represent the mean number of times a month that a student from Colorado cooks dinner, and mu2 represent this mean from Utah students. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen than Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is U1 equals U2. Use a level of significance 0.05. So I have to paste and cut this into a QIP file. And it's going to be a 2 sample or a pair 2 sample, right?
2 sample, yeah.
That noise it makes.
Sound effects with it.
Copy. Paste. And this is the freshmen's. And it's the freshmen's at Utah. I like to label things so I'm not forgetting them.
Mine won't work.
And then we go to our other one. There's more freshmen at Utah that they tested.
Yeah, we noticed that.
For some reason, it's not pasting here. Escape again. Copy. Paste. I make sure I have all my info here. One time I didn't do that. And this is the Colorado freshman. Okay. It says, what is the alternative hypothesis?
So says you suspect the freshmen from Utah cooked dinner for themselves a different number of times than the freshmen of Colorado. Determine a test. So it would be not equal to, because it doesn't say less or greater. It just says not the same. So it would be that second, or that third.
Number 2?
Yeah, that second one. And then the test statistic is 0.845.
The test statistic. Are we inverting the files to make it negative? No, it's just 0.45. 845.
Are we supposed to make it negative?
I don't know. We'll find out, won't we?
Yeah.
So it's 0.845.
Mm-hmm. And then the p-value is 0.411.
Correct. 0.411, rounding it up to the third.
Mm-hmm.
15. Okay. What decision do you make? Aren't decisions nice?
So it's greater.
We fail to reject the null hypothesis again.
Right, okay.
Do you understand why?
Yes.
Okay.
Determine a 95% confidence interval for U1 minus U2.
Determine a 95% U minus U2. So we have to subtract the 2.
Mm-hmm.
An estimate of the difference between U1 and U2, and put your answers below.
So you subtract the 2 means? Yeah, because that's what U is. Okay. Answered my question. Oh, determine
The margin of error. So we subtract the confidence interval from the mean. So that would be 5.147 3.420. And 5.47. 5.147 minus 4. You know what? What we have to do is we have to take the standard deviation, add it together, and divide it by 2 to get the mean, the standard deviation, and then subtract it from the confidence interval. Because we have 2. Does that make sense?
Shouldn't there be an equation for the margin of error?
There is an equation, but this is the easier way to do it, is subtracting the standard deviation minus the confidence level will give you the margin of error. So we're going to take standard deviation.
Oh, I see.
3.420.
Oh, that's smart.
Plus 45. Oops, I got to get my decimals right. 4.51. Oh, come on. My cat wants me to give them warm fuzzies here.
Oh, I know how you feel.
Right. His name is Brutus.
Cute.
3.442 divided by 2. Come on, Brutus. I can't be giving you hugs and loves right now. 3.4 517. 937 divided by 2 equals 3.969. Subtract 5.147. Okay. Brutus, cease. 5.147. Zero. I keep on putting my decimals wrong. Oh, that's what I'm doing wrong. Okay, back to number question 16 here.
No, stop. That's it. Drop it. No. 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 Stop.
Let's try it this way. Yeah, you did it. 2.214 plus 7.
Enough.
Lower bound. Well, moving on to 17, because I got to come back to that, Hannah.
Stop.
Okay.
Input the lower bound, question 17. It's negative 2.214.
Negative 2.214.
Yep. 18, input the upper bound. 5.147.
Okay. Okay. All right. Do you have to go to work?
I have to leave like in 10 minutes.
Oh, okay.
The question whether we need to invert these here to make them negative.
Which one?
We do have a negative 2.214. Do we need to make do we just take the information from our template here for our confidence intervals for our upper and lower? Or do we change them? You know how they inverted it on the lesson? Make them negative?
Oh. Let me see.
Let's try it this way. Plus. Negative 2.214.
Okay, so for the margin of error, I got 1.736. I found the equation for it and then just solved it out.
1.467. Tell me the equation in the thing so I can do it too.
Okay, can you see? I'm going to show that to you on the camera because it's kind of big. Can you see that one?
It's Z or T. It's T.
Yeah, sorry, that's a T.
Square root.
Uh-huh.
And it's what's the, is it S1, S12 square over N1?
Yeah.
Plus
Uh-huh.
S22 over N2.
Yeah.
Okay.
Oh, wait. No, I didn't. That's wrong. Times 1.96. That equation's right, but the answer I told you was wrong. I forgot to times it.
I like your resourcefulness, McKenna.
Let's go back and watch video. Yeah, I don't know how I would tell you that equation. I don't know how to word that. So yes, you should invert the answers. I submitted it.
So the 2.2.14, would that be positive and the other negative then?
So I answered negative 2.214, and that gives you feedback now, and it says the answer in SPSS is slightly higher than in Excel. So the answer given is the average between the two results. Your result should be close to the answer shown.
But did you get it wrong
Yeah.
as a negative?
No, it didn't say that. It said that it should be close. I don't know. Oh, yeah. So I missed 4. I don't know what that is supposed to mean. Okay. Yeah, well, I'm using my husband's computer, and he's got to do a group meeting, so I've got to go.
Well, I'm going to submit, and we can always use it, do it a second time here.
Yeah.
Okay,
Okay.
and I have to leave to work.
Okay. Have a good night.
Thank you for meeting with me.
Yeah. Thanks for meeting with me. See ya.